As the search for renewable energy continues, and the switch to electric cars still seems quite far away, bioethanol is a strong contender for an alternative fuel source, as it can easily be mixed with petrol. Most bioethanol is currently produced from sugarcane and corn, using a fermentation process from many single-celled organisms, yeast being one of the most accessible and common methods to do so. Let us outline the process of fermentation in yeast, creating the end product, ethanol. In the space between the cell wall and the cell membrane, sucrose is converted from a disaccharide into monosaccharides glucose and fructose through the enzymes invertase. These are then transported across the cell membrane via the transporter HXT. Once these initial steps have occurred, glycolysis begins with conversion of glucose into glucose 6-phosphate. The enzyme hexokinase does this through phosphorylation by ATP. Glucose 6-P undergoes an isomerization reaction where only the configuration of the molecule is changed. Therefore, the hexagonal structure of glucose 6-P becomes the pentagonal structure of fructose 6-P. In addition, fructose is phosphorylated with ATP and also becomes fructose 6-P. Now, both glucose and fructose, which have entered the cell wall, have been transformed into fructose 6-P. This molecule undergoes multiple transformations within the cytoplasm and becomes phosphoenol pyruvate. The phosphate group is transferred from phosphoenol pyruvate to ADP, thus creating ATP and pyruvate. Pyruvate can either be fermented into ethanol or oxidized via the citric acid cycle. With the absence of oxygen, the enzyme pyruvate decarboxylase converts the pyruvate into acetaldehyde. In the final step of this process, the ADH1 enzyme transforms the acetaldehyde into the final product ethanol, which is diffused across the plasma membrane. And why is this long process we just described even helpful? Well, once the bioethanol product is complete, it can be applied in numerous useful applications. One such application is in combustion processes, where it produces less carbon emissions in comparison to petrol or gasoline. It can also be used as fuel for fuel cells, as feedstock for chemical companies, and lastly to fuel cogeneration systems, which produce heat and electricity. If a cheap, reliable method for producing bioethanol on a large scale is found, then it could have great potential as a renewable energy source.